Welcome back, everyone, to another deep dive. This time, we're going to be looking at some research that's really blurring the lines between human brains and computer vision.
Oh, wow.
Yeah, you ready to get meta?
Absolutely. Let's do it.
All right, so the jumping off point for this deep dive is this research paper with a super catchy title of Parametric Enhancement of PerceptNet, a human-inspired approach for image quality assessment.
Catchy indeed.
Yeah, so this comes to us from some brilliant minds over at the Image Processing Lab at the Universitat de Valencia. And basically what they're trying to do is build a computer model that sees the world more like we do.
Yeah, that's right. I mean, you think about it, deep learning models are already really good at like image-related tasks, right?
Hmm.
Recognizing objects or faces. But they're kind of like black boxes, We know that they work, but we don't always know why they work.
So they're giving us the right answers,
Right.
but we have no idea how they're getting there.
Exactly. And that's where this PerceptNet comes in. It's like a specific kind of deep learning model, and it's designed to judge image quality, but with a twist.
Okay.
The researchers, they wanted to make it not just get the same results as humans, but also mimic the way that our brains process visual information.
Ah, so instead of just saying like this picture looks good or bad, it's actually trying to figure out
Right.
why a human would say that.
Exactly.
That's so interesting.
Yeah, and one of the cool things about this approach is it makes the model more efficient.
Okay.
Because by building in what we already know about human vision, they can reduce the amount of information that the model has to learn from scratch.
Okay, so hold on, I got to stop you right there.
Sure.
When you say incorporate what we already know, what do you mean by that?
Well, imagine you're like, building a robot, right?
Well, yeah.
You could just give it a pile of parts and say, figure it out.
Good luck, little robot.
Yeah, exactly. And it would take a lot of trial and error and who knows how long.
Yeah.
But what if you gave the robot like some blueprints or even like, some pre-assembled parts? Why, it would be a lot faster.
Yeah, it makes a lot of sense.
So like those blueprints, those are basically the rules of how human vision works.
Okay.
And those pre-assembled parts are these things called parameters.
Okay.
Think of them like settings on a camera.
Okay.
So instead of letting the AI randomly adjust every single setting, the researchers can preset some of them based on what we know about how our eyes work.
Right.
So this way, the model can focus on fine-tuning, those specific settings instead of having to figure everything out by itself.
So you're basically giving it a huge head start.
Exactly.
Yeah.
I like it.
And in this case, they focused on mimicking those early stages of human visual processing. So what happens when, like, light hits your retina and gets sent to your brain?
Okay, so like the very first steps of how we see things.
Yeah.
What's happening there that they tried to put into this model?
Well, one of the key things is how we detect edges and contrasts.
Okay.
So our eyes have these special cells called center surround receptive fields.
Yeah. And it's kind of like if you imagine like a spotlight shining on a stage, right? The center is bright and then it gets dimmer around the edges.
Yeah.
Our eyes use that to spot edges.
Oh, that makes sense.
And then further on in the brain, we have these things called Gabor filters, which are like mini wavelets that analyze how those light and dark patterns are arranged in different directions.
Oh, wow.
Yeah, so it's how we see details and textures.
So we're talking serious image processing here. It's like
Oh, yeah.
our brains are running Photoshop before we even know what we're looking at.
Pretty much.
Whoa.
Yeah, and the researchers actually built layers into PerceptNet that directly correspond to those biological mechanisms.
Okay.
So they use mathematical functions like Gaussian, difference of Gaussians, Gabor functions, to actually shape how the model processes information.
So they're not just mimicking like the results of human vision, they're mimicking the process.
Exactly, step by step.
That is fascinating.
Yeah, it's a really fascinating approach, and you'll see it led to some pretty cool results.
Okay, I am officially intrigued. So how did they actually test this model out?
Well, they trained it on a data set of images with different kinds of distortions like blurriness or noise.
Okay.
And then they compared how the model rated the quality of those images to how actual humans rated them.
So it's like humans versus AI.
Yeah.
Who has the best eye competition.
Exactly.
Okay, I need details.
Okay, well, at first glance, it looked like the standard deep learning model was winning.
Really?
Yeah, it was scoring really high on those initial tests.
So AI was beating human vision.
Well, not so fast.
Okay.
So remember how we talked about those parameters?
Yeah.
Those pre-programmed settings?
Yeah.
Well, the standard model, it didn't have any of those.
Okay.
It was basically trying to learn everything from scratch, and it was doing a great job.
Oh.
Yeah.
Too good to be true.
Exactly.
Okay.
So it was exceeding what we call the maximum experimental correlation.
Okay.
And it's kind of like even with perfect vision,
Yeah.
there's some variation in how people judge image quality.
Right.
The standard model scores were so high, it was basically suggesting that it was seeing things even better than any human could.
So it's like it was cheating.
Yeah.
It was memorizing the answers instead of actually
Right.
understanding.
That's what we think happened. And when they tested it on totally new images that it hadn't seen before, the performance dropped.
Oh.
Yeah. So it was overfitting to that training data. It's like that student who crams for the test but then forgets everything the next day.
Yeah, totally makes sense. But what about PerceptNet, the one with the human-inspired settings?
Now, this is where things get really interesting.
Okay.
So PerceptNet, it didn't score quite as high initially,
Okay.
but it consistently performed well across all of the tests, even on those new images. So it wasn't cheating, it was actually learning to see in a more human-like way.
So slower and steadier wins the race.
You could say that. Yeah. So that model with the pre-programmed settings based on human vision, it actually ended up being more robust and reliable.
That's pretty amazing. But they took this bio-inspired thing even further, right?
They did.
Tell me about this bio-fitted model.
This is where it gets wild.
Oh, yeah.
Remember how I said those researchers could preset some of the model's settings, like parameters on a camera?
Yes.
Well, with the biofitted model, they basically hard-coded almost all of the settings to match what we know about human vision. Only the very last layer, the one that decides how important different features are for overall image quality, that was left for the model to figure out.
Wait, so they basically said, okay, here's how you see the world
Yeah.
using these rules based on like human biology.
Exactly.
And then just let it tweak a few details at the end.
Exactly. And incredibly, even with those limitations, the biofitted model still performed comparably to the standard deep learning model.
That is wild. So it's showing that you can get human-level performance in computer vision by basically forcing the AI to see through human eyes.
It seems that way, yeah. And it's not just about like the numbers. When they actually looked at how these different models were processing the images, they found some interesting differences.
Like what?
Okay, so let's take the example of gamma correction.
Okay.
You know how our eyes adjust when we go from like a bright room to a dark room?
Yeah.
That's gamma correction at work. It helps us to see details in both light and shadow.
Yeah, I'm glad my eyes do that automatically.
Right.
I don't want to have to adjust my gamma settings every time I walk through a door.
Exactly. It's super useful.
Yeah.
Now, the standard deep learning model was technically capable of doing gamma correction,
Okay.
but it did it in a way that actually altered the colors of the image. So it's like it learned a shortcut to get good results,
Yeah.
but it wasn't really seeing the image the way a human would.
So it's like I passed the test, but don't look too closely at my work.
Exactly.
Okay.
The biofitted model with those human-inspired settings, it preserved the colors while also correctly simulating that gamma correction. So it was actually seeing the image more like we do. And this wasn't just a one-off thing. They saw similar patterns throughout the whole model's analysis.
Huh.
So the biofitted model was consistently processing information in a way that was accurate and more aligned with human vision.
That's pretty incredible. It's not just about building AI that can see. It's about building AI that can see like we do.
Right.
What does this mean for like the future of AI?
That's a great question. I think the answer lies in the potential to create AI systems that are not only powerful, but also more understandable and trustworthy.
Okay, unpack that for me. How does mimicking human vision make AI more trustworthy?
Well, I mean, think about it right now. Most AI models are like those black boxes we talked about.
Yeah.
We don't always know how they're making decisions.
Right.
But if we can build AI that processes information in a way that's more aligned with our own brains, it could help us to understand their reasoning better. We might even be able to predict their behavior more accurately.
So it's like instead of just trusting the AI blindly,
Right.
we can peek under the hood and see how it's thinking.
Exactly. And that could have huge implications for everything from healthcare to self-driving cars, you know?
Yeah.
Imagine being able to trust an AI doctor not just because it gets good results,
Right.
but because you actually understand how it arrived at its diagnosis.
Yeah.
Or imagine feeling confident, riding in a self-driving car because you know that it's seeing the road in a way that's similar to how you would.
Right. You're speaking my language.
Right.
That level of transparency would be a total game changer.
For sure.
But are there any like downsides to this? What if mimicking human vision also means mimicking like our biases
Yeah.
and our limitations.
That is a great point, and it's something we need to be very careful about. If we're building AI systems based on human cognition, we need to be aware of the potential for those systems to inherit our own flaws.
Yeah, we don't want to create AI that's just as prone to making bad decisions as we are.
Exactly.
So how do we avoid that? How do we make sure that this bio-inspired AI is used ethically and responsibly?
Well, that's where things get a little more complex, and I think the key lies in...
Oh, come on, you can't leave me hanging like that.
I know, I know.
We're going to take a break.
We'll be right back after this quick break.
Don't go anywhere, folks. Stay tuned.
In recognizing that building ethical AI, it's not just like a technical problem, it's
Yeah.
a societal one.
Yeah.
We need diverse voices at the table, ethicists, social scientists, philosophers, all working alongside those computer scientists.
I like that.
Yeah, it's about making sure that the values that we embed in these systems, they reflect a broader understanding of what it means to be human, not just a narrow slice of it.
Yeah, it's like we're not just building AI.
Right.
We're shaping the future of our relationship with technology. And
Right.
that's a pretty big responsibility.
Absolutely. And it's a responsibility that we all share. As AI becomes more integrated into our lives, it's important for everyone to, engage in these conversations, ask questions, demand transparency from the people who are developing these systems.
Sensing a theme here. Transparency. Transparency.
Yeah.
It seems like that's really the key to unlocking the potential of this bio-inspired AI
I agree.
while also mitigating those risks.
Absolutely. The more we understand about how these systems work, the better equipped we'll be to use them responsibly and ethically.
For sure. So big picture time.
Mm.
What does this research mean for the future of AI? Are we on the verge of a bio-inspired AI revolution?
I think it's definitely a significant step in that direction. This research shows that mimicking human cognition, it's not just a theoretical possibility. It can actually lead to real-world benefits, in terms of performance efficiency and interpretability.
Yeah.
And as our understanding of the brain continues to grow, the possibilities for bio-inspired AI are just going to keep expanding.
It feels like we're just scratching the surface of what's possible.
Yeah, definitely.
What are some of the potential applications of this technology that you're most excited about?
Well, beyond image quality assessment, I think this approach could really have a huge impact on fields like medical diagnosis, drug discovery, personalized education. Imagine AI systems that can not only analyze medical images with incredible accuracy, but can also explain their reasoning in a way that doctors and patients can understand.
That would be huge.
Right, or imagine AI tutors that can adapt to each student's individual learning style and provide personalized guidance and feedback.
So we're not just talking about AI that's smart. We're talking about AI that's intuitive and empathetic.
Exactly. And I think that's what makes this research so exciting. It's not just about building machines that can think, it's about building machines that can think like us, with all the creativity and compassion and insight that comes with that.
Couldn't have said it better myself. Well, on that very inspiring note, we're going to wrap up this deep dive. Huge thanks to the researchers at the Universitat de Valencia for this really groundbreaking work. And to all of you deep divers out there, keep exploring, keep questioning, and keep those brains buzzing. Until next time, stay curious.
In building ethical AI, it's not just a tech problem, right? It's a societal one.
Yeah, definitely.
So we need lots of different voices at the table.
Right.
We need ethicists, social scientists, philosophers working with computer scientists.
I like that.
Yeah, it's about making sure that, the values that we're embedding in these AI systems really reflect a broader understanding of what it means to be human and not just, a narrow view of it.
Yeah, it's we're not just building AI at this point.
Yeah.
We're shaping the future of our relationship with this technology.
Exactly.
And that is a huge responsibility.
It is a huge responsibility, and it's one that we all share, you
Yeah.
know. As AI becomes more, a part of our lives,
Yeah.
it's important for everybody to be a part of this conversation,
Right.
to ask questions, to demand transparency from the people who are developing these systems.
I'm sensing a theme here. Transparency, transparency, transparency.
Right.
It seems like that's the key to unlocking the potential of this bio-inspired AI
I agree.
while mitigating the risks.
Absolutely.
Yeah.
The more we understand about how these systems work,
Yeah.
the better equipped we are to use them ethically and responsibly.
So true. So, big picture time.
Yeah.
What does this research mean for the future of AI? Are we on the verge of a bio-inspired AI revolution?
I think it's definitely a big step in that direction. This research shows that mimicking human cognition, it's not just theoretical anymore.
Right.
It can actually lead to some real-world benefits
Yeah.
in terms of performance, efficiency, interpretability.
Huh.
And as we learn more and more about the brain, the possibilities for bio-inspired AI are just going to
It
explode.
feels like we're just scratching the surface of what's possible.
I think so.
What are some of the potential applications of this technology that you're personally most excited about?
Well, beyond just image quality assessment, I think this approach could have a huge impact on fields like medical diagnosis, drug discovery, personalized education. Imagine AI systems that can analyze medical images super accurately, but can also explain their reasoning in a way that doctors and patients can understand.
Right.
Or AI tutors that can adapt to each student's individual learning style and provide personalized feedback.
Yes, we're not just talking about AI that's smart. We're talking about AI that's intuitive and empathetic.
Exactly.
That's pretty cool.
It is. And I think that's what makes this research so exciting. We're not just building machines that can think, we're building machines that can think like us.
I love this.
With all of the creativity and compassion and insight that entails.
Well said. On that inspiring note, we're going to wrap up this deep dive. Huge thanks to the researchers over at the Universitat de Valencia for this groundbreaking work. And all of you deep divers out there, keep exploring, keep questioning, and keep those brains buzzing. Until next time, stay curious.